Okay, we're talking about rates and ratios, and specifically we're going to be looking into what is a ratio, when is a ratio also a rate, and what do we mean by a unit rate? Okay. Well, very often when I start this in class, I have people answer the question, how many, or what's the ratio of girls to boys? Okay. And most of the time they're able to count up, say there's 12 girls, and there's 8 boys, and most of the time by the rate or the level that I'm teaching, which is high school algebra, most of them are pretty good at being able to write 12 over 8 or 12 to 8 or maybe 12 to 8, and they're also okay about knowing that if I had said the ratio of boys to girls, they would have reversed each of these, so it'd be 8 over 12 or 8 to 12, with a colon, or 8 to 12. So most of the time people are okay with that, and they're even all right with the idea of being able to reduce each of these down to, say, divide the top and bottom by 4, you get 3 to 2, and so on, or 2 to 3 down here. So for the most part, people have been all right with that. But I try to ask them, well, what do you mean by a ratio? And so I rewrite this information up here: 12 girls and 8 boys. And I ask people to compare those two numbers. Okay? And frequently they'll say something like, well, girls are better than boys, or something like that. But what I'm really meaning is, how would you say these two numbers compare? And very often they'll say, well, there's more girls than boys, and I'll ask, well, by how much? And some people will say, well, there's like 1.5 times as many girls, and other people will say, well, there's 4 more girls, and both of those are correct. 1.5 times as many, okay, or 4 more. Okay? Either one of those is a perfectly reasonable way to compare numbers. A ratio specifically compares this way. Okay? And I asked people, well, how did you get that? What mathematical calculation did you do? And eventually we fumble around and find that, well, they divided 12 by 8. Okay? In other words, they did this ratio, okay, which leads you to 3 over 2, which of course is 1.5. So a ratio is simply a comparison of numbers by division. Okay? So if I had told you that one person moved 2,200 pounds of hay, and another person had moved 550 pounds of hay, and I said, please compare how much work one person did to the other. If this was, say, Smith and Jones, okay, you might say, well, Smith did 4 times as much work as Jones did, or you could say that, let's see, 2,200 minus 550 do this. 1,650 more pounds. Now, if I ask you for the ratio of Smith to Jones, then you're going to end up writing 2,200 over 550, which of course will get you 4, or 4 to 1. That's how we frequently write that, 4 to 1 ratio. So a ratio simply compares numbers by division. So that's not what I meant to do at all. So we've looked at what is a ratio, and now we're going to look at the question of, well, when is a ratio also a rate? Well, remember, a A ratio is a comparison of two numbers by division. If I write something like this, 5 dogs to 3 cats, that looks like rats, okay? There's a ratio, okay? I'm comparing dog to cats. If I write 5 dogs per 2 days, maybe I own a dog training school or something, okay? Now I'm not comparing dogs and cats, I'm comparing dogs to a certain number of days. And what you'll notice is that the units were basically the same here. They were talking about pets or animals. Here the units are completely different. Okay? So when I look back at the previous example where I was doing 2,200 pounds, okay, compared to 550 pounds, okay, that was a ratio. Okay? But when I compare these, dogs to cats, or maybe I say 2,200 pounds per 3 days, okay, I'm no longer comparing things that are the same units. So we would call these a rate. So the distinction is a ratio is a rate when you're comparing numbers of different units. So we've looked at what is a ratio. We've looked at when is a ratio a rate. And now the question is going to come up with what is a unit rate? You'll be asked to do that in some of your work. And so I like to introduce it with this problem here. Suppose I go down to the store and I'm told that I can buy 16 ounces of ketchup for $3.79. Okay? If I'd like a bigger bottle, I can buy 21 ounces for $4.69. Okay? And when I go to stores, I like to do comparison shopping, so I ask myself, which one is the better deal? Well, it's kind of hard to compare those. It's hard to really see, yes, I got 5 more ounces for 90 more cents. Is that a great deal or not? And what most people start telling me is, well, how about if you just divide and find out how much each one is per ounce? So I'll grab a calculator here and type in 379 and divide that by 16. Okay. I get a number there. I'll do the other one, 469, and divide by 21. Get a number there. And then I'm going to interpret what these numbers mean. Okay. This apparently means it's about 24 cents for each ounce. Okay. And this one apparently is about 22 cents for each ounce. Okay. So what I've done is calculate how much 1 unit is, so now I can compare them more easily. I can tell this one's 22 cents an ounce, where this one was 24 cents an ounce, so apparently the bigger bottle is a better deal. And what you have done when you've calculated each of these quantities, that one and that one, each of those is considered a unit rate. So when you're given a question that says something like, you're going to pay $378 for 5 tons of some product, okay, what is the unit rate will be the question. And you'll simply calculate 378 divided by 5, and you'll find out that apparently it is $75.60 per ton. Okay? So to get a unit rate, you simply divide the cost by whatever number of units you're talking about. Okay, that's it.